All right, good morning. You're on to mathematics or arithmetic for grade 7. And today we'll be looking at the matter of factors and multiples. Factors and multiples. You've done this a lot in your primary school. You're in grade 7 will suggest that, or beginning grade 7 will suggest that you've had a very interesting primary school experience, and every idea you've gathered there will be needed in this class. So, before we talk about factors and multiples, it's important to have an understanding of when we say factors, multiples, where is this coming from? The whole journey begins with a simple knowledge of something we call numbers. And that's why when we started by looking at counting system. One of the first use of a number is to express quantity or how big or how small a thing is. Another use will be to show how we can count. Hence, we talked about counting system. Now, today we're going to look at how we will begin to interact with numbers. And the simplest type of number that enables us to understand this interaction is what is called natural numbers. So what then is a natural number? A natural number, first of all, is a whole number that's essentially always what? Positive. A natural number is whole and positive. When we say a whole number, we mean a number that doesn't have a decimal part. Sometime later, we'll go into that. So maybe we want to look at what then is a whole number. Any number we can form from 0 from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Either as it is or recombination. It's a whole number. So these are basically the building blocks for whole numbers. And what I've written on the board are essentially building blocks for what? Whole numbers. So a whole number can be a single digit number, like 0. It can also be 2-digit numbers, like 20. It can also be 3 digits. So with this, we begin to build up whole numbers. The most important number when it comes to the journey of factors and multiples is what we call prime. I'll call them prime numbers for now. As we proceed, we begin to see other ideas coming in. But I'm bringing it. So these are things you're already used to in your primary school, but we want to see how we now use them in a secondary school experience. Now, prime numbers. What are prime numbers? You've been told that prime numbers are essentially numbers that have 2 factors. What are these factors? 1 and itself. Prime number is any number that has 2 factors, 1 and itself. So the only number, sometimes some writers would argue and say, let's keep 1 away. But let's stick to a number that has 2 factors, 1 and itself. So what it technically means is that if we forget about 1, it means a prime number can only be divided by itself. So think of any number other than 1, such that it can only be divided by itself. So we said a prime number. Now, any number that is divisible by itself alone, other than 1, is a prime. So there's an exercise we usually embark on when it comes to discovering prime numbers. And I'm going to advise you to do that when you're free at home. We simply will write 1. I'll take it to 30 just to show you something. All right, so now let's go ahead and decode prime numbers. There's a method that is used for this, but let's just use 1 to 30 to do this. Now look at this. 1 is not treated as a prime number because we had said that for a prime number, we must have 2 distinct numbers. It must have 2 distinct factors. 1 has just 1 factor, which is 1. So that eliminates 1 from our choice of prime numbers. So we would say that 1 is a neutral number. Sometime later, you get to understand this better. Now we'll come to 2. If you look at 2, we can get 2 factors from it. 2 can divide 2. And when 2 divides, what do you get? 1. Is that not? So we say this is good. We look at 3. 3 can divide itself, 3. And when 3 divides 3, you get what? 1. So we say this is good. When we get to 4, 2 can divide 4. Is that not? Now, before I proceed, take note of this. Every number is a factor of itself. Every number is a factor of itself. So 4 has a factor called 4. It has 1 as a factor. So here it is. For all whole numbers, there are 2 distinct factors they must have. They must have 1. They must have themselves. So if those 2 factors are existing, if you get a new factor, it eliminates it from being a prime number. So that's the easiest way to get our prime numbers. Just if you can see another factor other than 1 or itself, that number cannot be a prime factor or a prime number rather. So look at 4. 4 can divide 4, that's 1. 1 can divide 4, that's 2. 2 can also divide 4, so it cannot be. We remove it. It's not possible. Let's go to 5. 1 can divide 5. 5 can divide 1. Can you think of any other one? No. So we say this one is there. Let's go to 6. 6 is an even number. Now, at this point, I will introduce another idea. 2 is the only prime number that is even. See the way we're building prime numbers now so that you understand how these things work. 2 is the only prime number that is what? Even. So, with that said, we knock off every other even number because there exists only one prime number that is even, and that number is what? 2. So, when you are not listing prime numbers, you cannot list an even number anymore. So, the big question will be, what then is an even number? An even number is any number that ends or is 0, 2, 4, 6, and 8. So these are even numbers. I'm going to put E on top. E will mean even. So all these numbers you're having E's on top are called even numbers. Now, look at these ones. Now, I'm going to be putting a cap on. All these numbers are called what? Odd numbers. So I'm going to put O on top of them. All these are called odd numbers. So even numbers are numbers that are 2, 0, 2, 4, 6, 8, or end. Or numbers that end with what? 0, 2, 4, 6, 8. So when you see numbers in this category, we call them even numbers. If they end otherwise with 1, 3, 5, 7, and 9, we say they are what? Odd numbers. Just to help you connect with what we're doing here. So we've gotten 3, we've gotten 2, 3, 5, and 7. So I'll pause and I want you to try your heads on trying to see what are the remaining prime numbers here. I give it to me on the chart. All right, so look at this. We said a prime number will always have 2 factors, itself and 1. Look at 7. Apart from 1 and 7, what else can divide 7? Nothing else. So this is a prime factor, a prime number. So when I use factor, don't mind me. Pardon my unnecessary use of factors. Technically, I will try to get back to that much later. But just know that if you hear factors from my mouth from now, I mean numbers. So look at 9. 9 is divisible by 3. Beautiful, beautiful. Okay. All right. I'll come back to that. Look at 9. Is 9 a prime number? Of course, no. Because 9 is a multiple of 3, which brings me to the second concept, or rather the third concept now. The first thing I said about prime numbers is this one. A prime number must have 2 factors, itself and 1. 1 was not a prime number because it has 1 factor. That's what eliminated 1 from being a prime number. Now, having said that, the next key idea I brought in was this. 2 is the only even number. 2 is the only even number that is a prime. 2 is the only even number that is a prime. So any other even number or even numbers cannot be a prime. Second idea I gave. Now coming to the next idea. Any number that is not the first multiple of that number, of that prime or number, is not what? A prime number. Now let me explain. Maybe the statement may have been ambiguous, but let me try to explain or recalibrate that statement. Now, 9 is the third multiple of 3. So it cannot be a prime. So if you're reading multiples of numbers, technically, if that multiple exists as a more than the first multiple of previously established primes, we cannot call that a prime number. So this is not. So the next thing you do now is to eliminate all the primes of what? 3. But before we do that, there's something I missed out. 5 also is the only prime, the only number that ends with 5 that is a prime. So any other number that is a multiple of 5 or ends with 5 cannot be a prime. It also maps with a concept of multiple, but just like it's obvious. So any number that ends with 5 is not a prime number, except it is just 5 alone. Same thing with multiple of 3. So we check 3, 6. Now we said even. So when we're counting multiples now, we don't need to bother ourselves about the positive multiples now. Or rather, the even multiples. So 3, 6, 9, 12, 15, 18, 21. 21 cannot be there. 24, 27 cannot be there. So if you look at this, based on what I've done on the board, we have a clear picture of the prime numbers. So let's assume I want to lock between 1 to 100 of the prime numbers. Let's look at what we have now. I'm saying 2, I'm saying 3, I'm saying 5, I'm saying 7, I'm saying 11. Now, to make it simple, I use what I call the concept of 5s. I always list my prime numbers in 5s. I do that intentionally to help students capture it quickly. Now, the next one will be what? 13. Next one will be what? 17. The next one will be what? 23. Next one will be what? 29. So I'm going to test to see how well you understand the concept now. The next one will be 31. Now, I'm expecting 25 prime numbers. Between 1 and 100, we have 25 prime numbers. So using the ideas I've given to you thus far, try to see if you can fill up the remaining ones. Try to see if you can fill up the remaining ones. All right, so let's go. All right, so after 33, 31, the next prime factor will be 37. How? We can't say 32. 32 is even, so it's out of it. We can't say 33 because 33 is a multiple of 3. We can't say 34. 34 is even. We can't say 35 because 35 ends with 5. We can't say 36 because 36 is an even number. So the next number we should have will be what? 37. 38, no, even. 39, multiple of 3. So the next number, 40, no. The next one will be what? 41. The next will be 43. The next will be 47. The next will be 53. We can't say 49. No, 49 is 7 times 7. 49 is a perfect square. We can't say 50. No, it's an even number. We can't say 51 because 51 is a multiple of 3. We can't say 52 because 52 is an even number. Then we say 53. Are you seeing that? So I'll pause again and see how you cope with that. Okay, so let's look at the next set. 54 is not there. 55 is not. 54 even. 55 ending with 5. 56 is not there. 57 is a multiple of 3. 58 is an even number. 59 will be the next one. Remember that any number we are picking must have just 2 factors, itself and 1. So this one will now be what? 61. 60 is not there. 60 is an even number, so 60 cannot be there. 62 cannot be there. 63 cannot be there. 64 cannot be there. I hope you know why. 65 cannot be there. 66 cannot be there. 67. 68 even. 69 multiple of 3. 70 ends with 0. 71, yes. 72, no. 73, yes. 74, no. 75, no. 76, no. 77, multiple of 7, no. 78, no. 79, yes. 80, no. 81, no. 82, no. 83, yes. 84, no. Even. 85, no. Ends with 5. 86, no. Even. 87, no. Multiple of 3. 88, no. 89, yes. 90, no. 91, no. Multiple of 7. 92, even, no. 93, no. 90 what? 4, no. 95, no. 96, no. 97, yes. I think we've missed one. Let's look at this very well. We've missed one. We should have 25. Look at that very well. There's a number we have missed. Let's figure that one out. Have you seen it? I think I figured it out. We missed 19 from the numbering. So this should have been 19, 23, 29. So it's important that you know this, that between 1 to 25, you have what? 1 to 100, you have 25 of them. So that's your check. So this will be what? 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, So you don't need to memorize them. You just need to know how to get them. 73 at this stage, rather, 79, 83, 89, and 97. So that's 25 of them. So from 1 to 100, we have 25 of them. So your assignments will be to try from 101 to 200. Between 101 to 200, try to write out the prime numbers. I'll just give a little hint. Between 101 to 200, you have 21 of them, 21 prime numbers. 21 prime numbers exist. So between that, you're going to have 21 prime numbers. So try it out and see how you're going to get them done.